In this video, we will master the concept of exact differential equations from your semester 2 of Applied Mathematics 2 of engineering. Okay, let's look at what is the form of exact differential equation. Exact differential equation is a differential equation which is written in the form mdx plus n dy is equal to 0. Okay, that's the form or format of exact differential equation. Here, both m and n both are functions of x and y. Okay, m is a function of x and y, and even n is a function of x and y. Okay, remember that. Now, there is a condition that should satisfy in order for the equation to be considered exact. Okay, what is that condition? Let's look at that. So the condition is you take two derivatives. You take partial derivative of m with respect to y. You take partial derivative of m with respect to y, and you take partial derivative of n with respect to x. Okay, if these two derivatives come out to be equal, such a differential equation is called exact. So, okay, so this is the condition. If this is true, if true, differential equation is exact. Okay, so that's how you check if the differential equation is exact or not. If the differential equation is exact, the solution of such a differential equation is given by integration of m dx plus integration of n dy is equal to 0. That's the solution of that exact differential equation. Now, there is a thing that you have to keep in mind here. There is a small thing that you have to keep in mind here. In order to integrate m, whenever you integrate m, remember that m is a function of x and y and n is a function of x and y. Both are different functions of x and y, but essentially they are functions of x and y. When you are integrating m, remember which is with respect to x. Okay, we are integrating m with respect to x. Remember that you have to keep y as constant. Remember, you will treat y as constant. And when you are integrating n, the one thing you have to keep in mind, since you are integrating with respect to y, you only have to take the terms free from x. Take only the terms free from x. Since you are integrating with respect to y, you have to take the terms free from x, and in order to integrate m, treat y as constant. If you remember this rule, you will be able to solve every question of exact differential equation. Okay, we'll look at few examples. Let's start by looking at example. Now let's convert this equation in terms of m dx plus n dy. Just cross multiply this. So therefore we have so dy times this term. So I have sine x plus x cos y plus x times dy plus this times dx. So y cos x plus sine y plus y into dx. This is equal to 0. Now remember that this is of the form m dx. Whatever is with dx is m. So this is your m and this is your n. Okay. So now we need to find two derivatives here. Okay, we need to find two derivatives. I'll first write the values. So I have m is equal to y cos x plus sine y plus y. Okay, and I have, let's first differentiate. All right, let's just write the value of n. N is sine x plus x cos y plus x. Okay, I have those two values. Remember, we need to take two derivatives. We need to take derivative of m with respect to y. We have to take derivative of partial derivative of m with respect to y. And then we have to take partial derivative of n with respect to x. Okay, the partial derivative of m with respect to y. Remember, with respect to y, x is constant. So if you want to differentiate this, cos x is constant. So you have cos x. Derivative of y with respect to y is 1 plus derivative of sine y with respect to y is cos y plus derivative of y with respect to y is again 1. Okay, so essentially you have cos x plus cos y plus 1. Okay, that's the partial derivative that you have. Now let's try to find another derivative, which is the derivative of n with respect to x. Derivative of n with respect to x. Now let's differentiate sine x. Derivative of sine x with respect to x is cos x plus x cos y. Remember, y is constant. When you're differentiating with respect to x, y is constant. So you have cos y times derivative of x with respect to x is 1 plus derivative of again x with respect to x is 1. So if you notice, this is the same thing. You have cos x plus cos y plus 1. Okay. So you have those two equations. Notice that those two are equal. Notice that since delta m by delta y is equal to delta n by delta x, therefore our differential equation is exact. Because that condition is satisfied, we can say that differential equation that we have is an exact kind of differential equation. Okay. In order to integrate or solve the exact differential equation, the solution that I have is, therefore, solution that we learned is, solution is, solution is integration of m dx plus integration of n dy is equal to 0. That's the solution that we know of. Okay. Now here we have to integrate m, but remember that while integrating m, we have to treat y as constant, okay? Because we are integrating with respect to x, we'll treat y as constant. And while integrating n, we have to remember we have to take the terms free from x. Because we are integrating with respect to y, we have to take all the terms free from x. Let's look at how to integrate it then. So we have integration. Let's substitute m. So we have y cos x plus sin y plus y. Y cos x plus sin y plus y into dx. Okay. Then we have plus integration of, we have to take all the terms free from x. If you look at n, if you look at n, is there any term which is free from x? Sin x is not free from x cos y is not free from x, and even x is not free from x. There is no term in this n which is free from x. So there is no term that we can include here. So we just write 0 dy. Okay. Because remember, we only take the terms here which are free from x, free from x. Okay, in this case, we don't have any term which is free from x, which is why we cannot take anything. So it's 0 basically. Okay, so which is equal to 0. Okay, also let's add a constant of integration c. Let's add a constant of integration c. Now, therefore, we are integrating here, remember, with respect to x, so y is constant. So you can just write y. Integration of cos x with respect to x is sin x plus integration of sin y with respect to x. Remember, sin y is constant. So sin y is also constant. Whatever left is 1. So integration of 1 with respect to x is x plus, remember, integration of y with respect to x. Y is constant. Integration of 1 is nothing but x, because there is, when you take y as constant, whatever is left is 1. Okay. Plus 0 is equal to constant of integration c over here. Okay. So therefore, your solution will become y sin x plus x sin y plus xy is equal to constant of integration c. Since there is a constant of integration c, remember that this solution is called as general solution. This solution is called general solution. Okay. If they would have given the value of x and a value of y, what we would have done is found the value of c and substitute it here. Then we would have got particular solution. Okay. But since they have not given any condition or values of x and y in order to find the value of c, we can just leave our answer here. Okay. I hope that makes sense. Let's move on to next example. In the next example, I have, it's already, if you notice, in the form of m dx plus n dy. It's already in the form of m dx plus n dy. Let's see if this is exact. Let's write the value of m first. So m is y into 1 plus 1 upon x plus cos y. Value of n is x plus log x minus x sin y. Okay. Now let's try to find derivatives of partial derivatives of m with respect to y and n with respect to x. So let's take partial derivative of m with respect to y, partial derivative of m with respect to y. So with respect to y, x is constant. So this 1 plus 1 over x is constant. Derivative of y with respect to y is 1 plus derivative of cos y with respect to y is minus sin y. So basically what I have is 1 plus 1 over x minus sin y is my delta m by delta y. Now let's see if what I get for delta n by delta x. Delta n by delta x. So with respect to x, derivative of x with respect to x is 1. Derivative of log x with respect to x is 1 over x minus, remember with respect to x, y is constant. So sin y is constant. Derivative of x with respect to x is 1. So if you notice both the terms are same, 1 plus 1 over x minus sin y. So therefore we can say delta m by delta y is equal to delta n by delta x. Since those two partial derivatives are equal, therefore we can say that our differential equation is exact. Our differential equation is exact. If our differential equation is exact, the solution that we can find, the is solution is integration of m dx plus integration of n dy is equal to 0. Okay. Remember that here we have to take the terms free from x. Take the terms free from x. And here you have to treat y as constant. Y as constant. Always remember those rules, okay? So therefore you have, let's substitute the values. So we have integration of m. Let's take m. So m is this y times 1 plus 1 over x plus cos y. So I have y times 1 plus 1 over x plus cos y. Okay, and this whole thing is getting integrated with respect to x plus integration. Remember, in n, we only have to take the terms which are free from x. So let's see, terms free from x. Again, here, x is not free from x, log x is not free from x, there is x here. Even x sin y is not free from x because there is x here. So we only had to take the terms which are free from x. So there is no term here which is completely free from x. Everything has x in it. So which is why again what we have to do is we just have to take 0 over here. Okay. In the next example, we'll see there will be a term which is free from x, and we'll take that term. Okay. Now let's integrate this. And actually, let's add a constant of integration c since we have already integrated. Okay. Now with respect to x, let's integrate this term and this term. With respect to x, remember y is constant. Okay. Remember y is constant. So you can write y times integration of 1 with respect to x is x plus integration of 1 over x with respect to x is log x. Okay, so that's the integration of this part. You keep y as constant and you integrate 1 and then you integrate 1 over x plus integration of cos y with respect to x. Remember, y is constant. If y is constant, cos y is also constant. You don't have to integrate it. You can just write it the way it is. And then whatever left is 1. So integration of 1 with respect to x is x is equal to add the constant of integration c, and that can be called your solution. Such a easy question it is. Okay, they give you 4 marks for this. Okay, in your exam they get such questions, you get for 4 marks. All right, let's look at next example. Let's look at next example a little bit where you have to do some work in order to differentiate and everything. Let's look at it in detail. First of all, you understand that this is your m, this is your n. Okay, you have your m and n ready. So let's write it down. Let's say your m is equal to y square into e raised to xy square plus 4x cube. Okay. Uh, and your n is, let's actually write it here only. N is equal to 2xy e to the power xy square minus 3y square. Okay, so we have our m and we have our n. Let's see if this differential equation is exact anyway. Let's try to find the partial derivative of m with respect to y. Partial derivative of m with respect to y. So let's start to differentiate this. If you notice this y square and e raised to xy square, you'll have to use UV rule or the product rule of derivatives, which says u derivative of v plus v derivative of u. Okay. So in other words, in order to differentiate this, you first have to keep y square constant. Derivative of e to the power xy square is e to the power xy square into derivative of xy square. Derivative of xy square, you are differentiating with respect to y. So x is constant and derivative of y square is 2y plus, now this is u derivative of v, okay, and then we have v, so e to the power xy square into derivative of u, okay, so which is y square, derivative of y square with respect to y is 2y, and 4x cube derivative with respect to y is 0, okay, so that's just 0 because x is constant with respect to y, x is constant. So we have this will become 2xy cube e to the power xy square plus 2y into e to the power xy square. Let's say those are the two terms. Now let's differentiate n with respect to x. Let's differentiate n with respect to x. Now with respect to x, y is constant. So this 2y is constant. So we can write it the way it is, 2y. Let's put a bracket. Let's put a bracket. And we have x into e raised to xy square. So that means we'll have to again use product rule or UV rule in x and e raised to xy square. So first we'll keep x the way it is. We'll keep x the way it is. Derivative of e raised to xy square. E raised to xy square. Derivative is e raised to xy square into derivative of xy square with respect to x. Y is constant. So y square is constant and derivative of x is 1. I hope that makes sense. You'll have to know the UV rule in order to do this, okay? Plus, now e raised to xy square constant, e raised to xy square, keep it constant, and take the derivative of x. So derivative of x with respect to x is 1 minus derivative of this with respect to x is again 0. I hope that makes sense because derivative of y square with respect to x is 0. So therefore we have just multiply this 2y inside, multiply this 2y inside. So we have again 2xy cube, this y and y square will become y cube, e raised to xy square, e raised to xy square plus 2y, this 2y inside, e raised to xy square. So therefore, since those two values are, if you notice, equal, this value and this value is exact same, that means that derivative of m with respect to y, that means therefore derivative of m with respect to y is equal to derivative of n with respect to x. Since these two derivatives are equal, therefore we can say our differential equation is exact. And since it is exact, the solution is, since it is exact, the solution of the differential equation is integration of m dx plus integration of n dy is equal to 0. I hope that makes sense. So therefore, remember that here, while integrating m, you have to keep y as constant. And here, take the terms free from x. Free from, only take the terms which are free from x. So x shouldn't be there here. Okay. So let's see. All right. So now let's substitute the values of m and n. So we have integration of, if you look at the value of m, we have y square e raised to xy square plus 4x cube, y square e raised to xy square plus 4x cube into dx plus. Remember that in n we only have to take the terms free from x. If you only take the terms free from x, so if you notice here, this first term contains x, so we cannot take this term. Only this term is without x, minus 3y square. So we'll only take that term. We'll only take minus 3y square. Minus 3y square dy is equal to, let's add a constant of integration c. I hope that makes sense. So now we have integration. Let's integrate this with respect to x. With respect to x, y square is constant. Let's integrate that. So with respect to x, y square is constant. Integration of e raised to xy square is e raised to xy square. Remember that we have to divide by the coefficient of x. Here x is the variable. Coefficient of x square is coefficient of x is y square. So in integration, we always divide by the coefficient of variable. Whatever the variable is, coefficient of that we divide by that. Okay. Plus, let's keep 4 constant. X cube, integration of x cube is x to the power 4 divided by 4 minus 3 y square. Integration of y square is y cube divided by 3 is equal to constant of integration c. Let's cancel this, cancel this, and we have the solution e raised to xy square plus x to the power 4 minus y cube is equal to constant of integration c, and this is your general solution of this differential equation. I hope that makes sense. In the next video, we'll see how to deal with non-exact differential equations which can be converted to exact. Okay. Thank you so much for watching till the end. See you guys in the next video. Take care.